Algebra 2 Notes 5.3 Solving Polynomial Equations. Let's take a look at some of these factoring techniques first that we've already learned this year. So go ahead and pause the video and see if you can try these first 4 problems. Alright, go ahead and check and see how you did with factoring. If there's any that you missed, maybe review how to do that process. Alright, let's jump down to the new type of factoring today. We have factor by grouping. So we're going to group the first 2 terms together and then the last 2 terms together and try to pull out the greatest common factor. So we can pull out an x squared and we're left with x minus 3. The second one doesn't really have anything you can pull out of it. So just think of x minus 3 staying there. So if I had to put a number on the outside, you can think of like a 1 being there. And then similarly to how we would rewrite x cubed plus x, we would pull an x out and then continue writing what we have left over. Right here we can pull an x minus 3 out front. So then we have x minus 3 times x squared plus 1. So that would be the factoring by grouping. All right, factoring with differences or sums of cubes. So we've done difference of squares, but what about cubes? So what you're going to do is figure out, first of all, which one are you using. So if there's a plus sign, you're using the sum equation or formula. If there's a minus sign, then it's the difference. So this one would be the sum of cubes because there's a plus sign. Okay, so from there, we want to try to think about writing 8x to the 3rd power as something all cubed, and then 27 as something cubed. So I think what times what times what is 8x to the 3rd. So we can break that apart to write it as 2x to the 3rd because 2x times 2x times 2x will give us 8x to the 3rd power. Okay, what times itself 2 more times is 27? That would be 3. Okay, so we can let our a be 2x, and we can let our b be 3. Okay, so if we let a be 2x, b be 3, we're going to use this formula here to factor it. Okay, so what is a? A was 2x plus b was 3. Then we're going to take that times a squared. Be careful with this step because it's not just 2x squared. It's actually going to become 4x squared. Here's where the minus comes into play. A times b and then plus b squared. So if we finish factoring this, we're just going to rewrite it. 2x plus 3 times 4x squared minus 6x plus 9. And now you have it factored. All right, we're going to look at another sum of cubes problem, but we're going to take it to the next step. So instead of just factoring it, we're going to continue on until we solve it. Okay, we want to find out what should x be. Now one like this, if you can recognize that you can take a 3 out right away, to take out that greatest common factor, really what you're doing is pulling it out of both of them. So you get 27x to the 3rd plus 64. And then what you can do, over here it says divide by 3. You can now divide everything by 3 because 0 divided by 3 is just 0. So we get 27x to the 3rd plus 64. Equals 0. So now we want to break it up into that a and b. So we're thinking what times itself 3 times is 27. And what times itself 3 times is 64. So for 27, you can take 3 times 3 times 3 to get 27, and then x times x times x to get x cubed. So 3x. That's going to be our A. And our B, what times what is 64? Would be 4. So then we're going to use the sum of cubes formula there. 3x plus 4 times 3x, and don't forget we got to square all of that, minus 3x times 4 plus 4 squared, still equal to 0. So then we can just simplify that. And then we're thinking, maybe can we factor this further? So we think about breaking that 9x squared up as 3x and 3x. If we try 2 and 8, that gives us 6x and 24x, not negative 12. Okay, if we try 4 and 4 to get 16, that gives us 12x and 12x. That would either be 0 or 24. So no matter what we try, this equation is not factorable. Okay, so therefore we need to find some different methods to solve this quadratic. So we got to think back to chapter 4. How do we solve quadratics? So we're going to set both of these factors equal to 0. And the first one's easy to find. You could have probably found it from the very beginning by just subtracting 192, dividing by 81, and taking the cubed root. And that would give you, if we divide by 3, x equals negative 4/3. So that's the obvious answer that you probably could have got without doing all of this. But since it's to the third power, there's also 2 more answers. Okay, there's 2 more times where this function has a solution. Okay, so we said this was not factorable, so we need to find other methods. So the method we're going to use is that quadratic formula. So try to write it out if you remember it. X equals negative b. See if you can go from there. All right, so there's the quadratic formula. Check if you got that right. And then it's like we have a brand new problem. So we use the sum of cubes to figure out our factors. But now I'm back to a quadratic, okay? So it's like a fresh start. So even though this has a's and b's in it, they're not the same as the original a's and b's. This one I do just like I did in chapter 4. I say, okay, my a is 9, b is negative 12, and c would be 16. From there, I'm going to plug that in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So go ahead and work to simplify that. All right, check how you did on that. 12 plus or minus negative square root of negative 432 all over 18. These have some big numbers, this problem does. So we want to break up that square root of negative 432. You can pull out that negative 1, and actually 144 goes into it, times 3. So you can rewrite it, 12 plus or minus 12i times the square root of 3 all over 18. We can take 6 out of everything. 2 plus or minus 2i times the square root of 3 all over 3. All right, so the 0 we originally got was negative 4/3, and then the ones we just figured out was 2 plus or minus 2i times the square root of 3 all over 3. All right, let's try number 2. This one's difference of cubes, but you do everything the same. The only thing that's different is in that formula. Those positives and negatives are switched around. So go ahead and pause the video and see if you can get this factored and possibly solve for those zeros. Okay, check if you had your factors correct. So x minus 5 times x squared plus 5x plus 25. Otherwise, pause it and review and see where you made a mistake. Okay, from there, we're going to set those 2 factors equal to 0. That first one's going to be that quick answer to get that we probably could have got without doing all this work, that x is 5. The second answer, that's going to be the ones where we get those imaginary numbers. It's not going to be factorable. So go ahead and do the quadratic formula and try to finish up those last 2 answers. So go ahead and pause the video and then you can check how you did. All right, so your solutions, zeros, roots, at times they could be called any of those, would be 5 and -5 plus or minus 5i times the square root of 3 all over 2. Notice there's two roots in there, -5 plus 5i squared root of 3 over 2, -5 minus 5i squared root of 3 over 2. So we satisfied that we should have had 3 answers since it was a cubic. All right, let's try the next one, factoring a quartic. All right, so your first step is to set it equal to 0. So how am I going to make this equal to 0? By subtracting that 4. So leave it in standard form, x to the 4th minus 3x squared minus 4 equals 0. Okay, now this looks a little intimidating at first, but if I can compare it to a problem that we've done before, similar to this, and think how would I factor this? Multiply to be 4, that has a difference of 3, 4 and 1. So I want that one to be minus plus. Notice this is the same basic example, only instead of breaking up x squared to be x and x, we're going to break up x to the 4th to be x squared and x squared. So it's got to be to the 4th, to the 2nd, and then a constant at the end for this to work. So then multiply to be 4, that has a difference of 3. We could go 4 and 1. Okay, if we check the inside, we get 4x squared. The outside, we get 1x squared. So to make that -3, we want the 4 to be negative, the 1 to be positive. All right, from there, you could actually factor that first one some more because now it's difference of squares. So a couple ways to do it. You could now break that up to be x plus 2x minus 2. We can't do that on the second one, though, because it's sum of squares. We don't have a way to factor. That one's going to get you imaginary numbers. So now just set all your factors equal to 0. So x plus 2 equals 0, x minus 2 equals 0, x squared plus 1 equals 0. Okay, we don't have to use the quadratic formula on this one because we have some shorter ways to solve the problem. So first, we can just subtract the 2. Second one, we can add the 2. And then for the last one, we don't need to use a quadratic formula. We can just move that 1 to the other side. X squared equals -1, and then take the square root of both sides. Don't forget when you take the square root, you need a plus or minus sign. Okay, so plus or minus, and then what is the square root of -1? It's just I. So this one was to the 4th power. So we needed 4 answers. Do we have 4 answers? Well, our first one we got to be -2. Second one we got to be 2. Third one we got to be a positive I. Fourth one we got to be a negative I. So you can write it like that, or you can just write plus or minus 2 and plus or minus I. All right, last one we're going to do today, factoring by grouping. This is similar to the problem that we did on the front side of the notes. All right, we can pull a 4x squared out of this first group, and we can pull a 9 out of this second group. See if you can do the next couple steps. All right, so if we pull out that x minus 1 that both of the groups had, we're left with x minus 1 times 4x squared plus 9. Now set both factors equal to 0 and solve. Go ahead and pause the video one more time. See if you can finish this up to find the 3 answers that we should be finding. All right, so if we finish this one up, we can find our 3 solutions. First one was x equals 1. The second solution and the third solution was plus or minus 3i over 2. So go ahead and work on the 5.3 assignment. If you need help with any of them, please feel free to email me and I will get back to you. Take care.